Let's tackle 4.5, variation in multivariable functions. With these, there's not a whole lot to it. A lot of it comes just from reading, and a lot of it's going to come from reading this beginning sentence right away. The way these are done, the very first sentence is generally going to be your equation. The second sentence is going to be your first set of numbers, and then your third sentence is going to be your answer, kind of. It really just is this is what you want to find. So when we look at this, we are looking at, suppose that y is proportional to the fourth power of x. This statement broken down, we'll write it first. Y is proportional to the fourth power of x. Cool. Y is equals proportional. This one's going to be an interesting one, and actually we're going to go back one. Whenever we say is, we're going to do an equal sign and the letter K. It'll make more sense here in a little bit, but is just like an equals K. Proportional just means that we are going to multiply. And then you just keep on going. The fourth power of x, very old way just to say x to the fourth. From here, take our new set of information and input it in. So for us, we know that y is 17 when x equals 6. There's going to be some nasty numbers, but we're going to say that 17 equals k times 6 to the fourth. Now we just got to do it. We got to figure out what 6 to the fourth is. We do know that 6 to the fourth is that. So I got 17 equals k times 1296. We're going to then divide both sides by 1296. 1296. And we get a constant value of, divided by 1296, 0.013. Cool. Generally what we would want to do is keep this k value in our calculators, as much of it as we can, so I'll even do 117, just rounding it a little bit more, just because the more that you chop off here, the more chance that whenever you run this a second time that you're going to get a slightly wrong number. Speaking of all of these, you're going to run twice. So let's figure out what numbers I need to use the second time. For us, they tell us that we don't know what y is, but we do know that x is 4. So we're going to use this exact same equation a second time. And we're going to say that y equals our k value, which is the 0.0131117 times my x value, which in this case is 4 to the power of 4. So again, since this is already in my calculator, I can take this, multiply it by 4 to the fourth. And this is what I'm going to get. 3.3 3, 5, 8. The reason why I did that, it wants me to round to 2 places. So this is an 8, meaning this 5 will go up to 3.36. And if we did it right, we should be dancing. Perfect. Again, a lot of this is just going to come back to the same things over and over and over. Read the first sentence and it will tell you what type of equation you need to make. So the distance, so it doesn't give us letters, but use letters that make sense. So for me, the distance that a free-falling object falls is, all of that can be summed up as the letter D. D for distance. Distance is, and remember that whenever we say is, we're going to do equals K. So distance is directly proportional, multiply, to the square of the time it falls before it hits the ground. So square of the time, again, we're going to look at time. So I'm going to do a t, and I'm going to just square it. So t squared. So d equals k times t squared. And now we're going to use the information that they give us. 84 feet in 3 seconds tells me that the distance was 84 feet. Equals k times 3 squared. 84 equals k times 9. We're going to divide both sides by 9. K equals whatever that is. Sorry. Let's do it. So clear it. Clear. Maybe. Oh, clear it. And we are going to do 84 divided by 9. And we'll get 9.3333. Again, the more numbers you include, the more accurate your final answer is going to be. So again, we're going to take that, and now we're going to figure out how far the object would have fallen at the end of 7 seconds. So I do not know the distance that my object is falling. I do know that the k value is 9.3333. I'm going to multiply that by my new time, which is 7 seconds, and it's squared. So I can do this part in my head and say that this equals 9.3333 times 49. So in my calculator, I can just type this, multiply it by 49, and I get a distance of 457.33 feet. I'll double check that real quick. Yep, 457. So we're going to do 457.33. Find the mathematical model. So this one is just asking you to find the model of whatever sentence they're going to say. P varies. Varies is where we get into that is. We're going to say equals k. Jointly just tells us that there's more than one thing happening, and the next part is where it tells us what's happening. The product of r and t, so we're going to take k, multiply it by r. We're going to also multiply that by t. Inversely means to divide. We're going to put this over, all over, whatever is inversely proportional to it, in this case, v. Gross. So this is what we put into here. Here. Too many screeds, and they're all running into one another. So P equals division sign. I will tell you, whenever it is a lowercase p, make sure you are using a lowercase p. If it is a capital R and a capital T, make sure that this is also a capital R and T. K is lowercase. So K, RT, over a capital V. And again, you jump right back in to more of these. This one is asking us to solve. And they're going to use different letters this time, but the same general idea throughout all of it. A varies directly as the square of B, so B squared, and inversely as the cube of C. So we have this. If we wanted to, we could go through. I think this is erase. And we can make it look just a little bit prettier. Okay, now we have our equation. Now you're going to plug in everything that you know, which for this first time through tells us that A equals 176 when B is 8 and C is 4. So 176 equals K times 8 squared over 4 to the third. 176 equals K times 64 over 4 times 4 is 16. 16 times 4 might be back to 64. Well, let's find out. Let's do 4 to the power of 3. 64. Well, 64 divided by 64, well, that is gone. So K equals 176. While I'm circling this K, it's just a reminder of what K is. It doesn't actually give me an answer. I don't necessarily care about the letter K. I just need to use it the second time through. So let's use it. When we come up here the second time, we again look up here, and it says find A. So since it says find A, I have no idea what A is. I do know that B is 3 and C is 7. Oh boy. So A equals my K value, which is 176, times my B value, which is 3 squared, over 7 to the third. Running all the way across my screen. Let me come back. I do know that A equals 176. 3 squared is 9 over 7 to the third. 3, 4, 3. So I'm going to take 176, multiply that by 9, and I get this big old number. I'm going to divide that by 343. A will equal 4.618. So 4.62. 4.62. The lifting force F exerted on an airplane varies jointly as the area A of the wing's surface and the square of the plane's velocity V. Again, you are doing all of this all over a bunch of times. And unfortunately, with variation, there is no quick way of doing variation. This is as fast as it goes. It's just time consuming. So Here we go. Lifting force F. We'll just restart that. That one looked a little bad. Lifting force F exerted on a plane wing varies jointly as the area A of the wing's surface and the square of the velocity. There's usually never any addition or subtraction. If there is, it'll be very obvious that there is addition or subtraction, and when that does occur, put that in parentheses. But here we have a very basic F equals K times A times V squared. Again, you're going to plug in what you know and see what happens. So, if we read through this, the lift on a wing with an area of 250 square feet. So the area is 250. The force is 2,200 pounds because we are flying at 250 miles an hour. It wants us to find the lifting force if the speed is 170. What's nice is that it doesn't give us a new area, mostly because we're not flying a new plane. We're using the same plane, so the area is still 250. But again, we need to solve it the first time. So the force of 2,200 equals K times 250 times the velocity of 250 squared. 250 times 250 times 250, this right here is just 250 to the third. Either way, we are about to experience a very large number. So, I'll scoot it up just a little bit. 250 times 250 squared. Gross. We're going to double check that one more time. 250 times 250 times 250 is an absolute monstrosity. Divide by 15,625,000. K equals a very, very small number. Memory save this. We're going to do 2200 divided by memory recall. Gets us 0.123148. That's my K value. Gross. Now we got to plug it in. So again, we're going to go over here and we're going to solve it. Again, I do not know my force. I do know my K value of 0.123148 times my area, which is still 250, times my velocity of 170 squared. So because of how this is just multiplication, I'm just going to go order from left to right with a little bit of math kerfunkling on this far right. So I'm going to take this, I'm just going to multiply it by 250. And then I'm going to multiply it again by 170 and again by 170. Again, 170 squared is just 170 times 170, so it's all just multiplication in the end. The force that we would be experiencing would be 1,117.28 pounds. It says round your answer to the nearest integer if necessary. So because it's asking for the integer, all we're going to do is take a look right here. Don't care since it's not a 5 or above. So 1,017 pounds. Do, 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 do. Bookstore manager observes that the number of magazines sold seems to vary. Again, this is a variation. It includes the word varies, so we might as well jump straight into it. Magazines sold. I'm going to do sales varies inversely as the price. Again, if we want to clean this up just a little bit and say S equals K over P. So if the store sells 410 magazines, so sold for 10 at a price of $5.60, how many does he expect to sell if he lowers the price to 410? Let's help this man out. I say man. Yeah, it's a he. All right. So S is 410 equals K over $5.60. Oops, there we go. Because this is on the bottom, I'm actually going to multiply both sides by 560. So K equals 410 times 560, so 2296 is my constant value. We're going to use that over here. So sold, we don't know how many we will sell. 2,296 over $4.10. Thankfully, this number is just the number on top, so we're going to take it and divide it by 410. And supposedly, we will sell 560. Round your answer to the nearest integer. Always check that last direction, because sometimes they'll sneak some weird ones in there. And on to the next. This one is a long one. I will freely admit that the variation section takes a hot minute. So, the safe load, capital L, supported at both ends, varies jointly. So we're going to have a bunch of stuff. So K times the width, W, and the square of the depth, and inversely as the length, lowercase l. Okay. So now that we have this, let's figure out what they want us to know. We have a width, depth, length, load. A wooden beam 3 inches wide, 9 inches deep, and 3 feet long. Holds a load of 37,732 pounds. What do they need us to know? what load would a beam, so again, I do not know my load, W, D, and L. So now we're going to do a 6-inch wide beam, a 6-inch deep, and 11-foot long of the same material. Alright, a bunch of this is just plug and play, see what we end up with. So 37, 732 equals K times 3 times 9 squared over 3. Okay. Math says that if I multiply something by 3 and I divide something by 3, they didn't really do anything. So now I have 37, 732 equals 9 squared is 81 times K. So I'm going to divide by 81 to get a new K value. Yes, yes, yes. I know. So, calculator, where art thou? We're going to take 37, 732 divided by 81, gross, we get 465.827. K value. Run it again. Run this again, but with new numbers. L, we do not know. K, we do know. 465.827 times 6 times 6 squared. 6 squared divided by 11. This stuff over here is just 6 times 6 times 6 times 6 times 6 times 6. There we go. So again, I'm going to leave this in the calculator screen because it's a little bit more precise than just saying 0.827. So I'm going to take this, I'm going to multiply it by 6. I'm going to multiply it by 6 squared. And I'm going to divide that by 11. Interesting. We'll see if my calculator worked. 9147.15. Interesting. Oh, it is longer and not as deep. That should work. Again, nearest integer. So we're going to take a look at this 1, ignore it, so 9,147 pounds. 9147, cross your fingers, and it worked. Suppose that y varies inversely as the cube of x. So again, y varies inversely as the cube of x. Y equals 14 when x equals 12. What is y when x is 13? So let's do it. 14 equals k over 12 to the third. Well, first thing we got to do is find out what 12 to the third is. 12 to the third. So I get 14 equals k over 1,728. Because I'm needing to solve for k, I'm going to multiply both sides by whatever I'm dividing. from k equals 1,728 times 14, 24,192. So up here, y equals 24,192 divided by 13 to the third. Gross. I don't trust it. 13 to the third. So y equals 24,192 divided by 2,197. Let me say 24,192 divided by y equals 11.011. It says around to 2, so I just need to write 3 of these out. 1 does not change, so y equals 11.01. And that should get us the end. Hey. So I could continue over to certify. Certify is just a bunch of the same stuff all over again. Again, read the first sentence. That will give you your equation, and then use your numbers generally in order. They don't go anything too crazy. But with that, this should wrap up Chapter 4, and we'll be looking at Chapter 5 next. Thanks, and have a good one.